Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. Find the temperature of a black body if its spectrum has its peak at part A lambda m, that is maximum wavelength or peak wavelength, equal to 700 nanometer. Nano standing for 10 to power minus 9. This is within the visible electromagnetic spectrum region. Okay, visible. Part B is lambda m, that is peak wavelength or maximum wavelength, is equal to 3 centimeter in place of 700 nanometer. Okay, 700 nanometer in part A, while only 3 centimeter, centi meaning 1/100th, that is 1/100th part of a meter, 3 centimeter. Okay, this is within the microwave region of the electromagnetic spectrum. Okay, and part C, lambda m or peak wavelength or maximum wavelength is equal to 3 meter, not 3 centimeter. Okay, 3 meter, 3 full meter, while in part B 3 centimeter, that is 1/100th part of meter, while in part A 700 nanometer, nano meaning 10 raised to the power minus 9. Okay, so in part C, lambda m or maximum wavelength or peak wavelength is equal to 3 meter, and this is within the frequency modulation radio waves. Okay, part A, in part A, visible light is under consideration. In part B, microwave region of the electromagnetic spectrum is under consideration, and in part C, frequency modulation radio waves are under consideration. Now we come towards its solution, but before starting our solution in a formal or regular manner, we will have to go through a few snapshots. Okay, a few or perhaps only one snapshot. Okay, and this snapshot has been taken or chosen from the book University Physics by Young Friedman. Okay, Roger Young Friedman, and one more author, I do not remember at this time. Okay, this snapshot says that this snapshot is about Wien displacement law for a black body. Okay, according to Wien displacement law for a black body, lambda mt is equal to 2.90 into 10 raised to the power minus 3 meter Kelvin, where lambda m is the peak wavelength in spectral emittance curve. Okay, lambda m is peak wavelength or maximum wavelength in spectral emittance curve, while T is absolute temperature of black body. Okay, lambda m is peak or maximum wavelength in spectral emittance curve, while capital T is the absolute temperature of black body, which is equal, and this product is equal to 2.90 into 10 raised to the power minus 3 meter Kelvin, that is to say 2.9 millimeter Kelvin, because 10 raised to the power minus 3 can be alternatively designated as milli. Okay, similarly 10 raised to the power plus 3 can be designated as kilo, and 10 raised to the power minus 6 can be designated as micro, and 10 raised to the power minus 9 can be designated as nano. Similarly, 10 raised to the power plus 9 can be designated as a giga, and 10 raised to the power plus 6 can be designated as a million or mega. Okay. So, dear students, we will use this formula to solve our problem. And quite simple, after putting the values, we will get our answers, three answers, okay, one by one. According to Wayne displacement law for a black body, lambda m, that is maximum wavelength or peak wavelength, into temperature of the black body is equal to 2.90 millimeter Kelvin, or 2.90 into 10 raised to the power minus 3 meter Kelvin. This implies that if we keep temperature on one side of the equality, then lambda m, that is maximum wavelength or peak wavelength, will be shifted on other side of the equality, and it will become in the denominator. Okay, before shifting it is in the numerator, it is multiplying with t, but after being shifted on other side of the equation, it will be divided and it will become in the denominator. Okay, now our formula has taken the proper shape, which will provide us three values, which will be our three answers. Okay, now in part A, we use lambda m, that is maximum wavelength or peak wavelength, equal to 700 nanometer, where nano stands for 10 raised to the power minus 9. So this first expression alternatively becomes equal to 2.90 into 10 raised to the power minus 3 meter Kelvin divided by 700 into 10 raised to the power minus 9 meter. Okay, dear students, here meter occurs both in numerator as well as denominator, so this meter will be cancelled with the meter. So our t will become alternatively equal to 2.90 into 10 raised to the power minus 3 into 10 raised to the power plus 9 Kelvin over 700. Okay, dear students, because 10 raised to the power minus 9 in the denominator is equivalent to 10 raised to the power plus 9 in the numerator. Okay, that is to say, nano in the denominator is equal to giga in the, what I have said, nano in the denominator is equal or equivalent to giga in the numerator. Okay, nano in the denominator and giga in the numerator are alternate or equivalent terms. Okay, so dear students, here 2.90 into 10 raised to the power minus 3 into 10 raised to the power plus 9 Kelvin divided by 700 alternatively becomes equal to 2.90 into 10 raised to the power plus 6 Kelvin divided by 700, because 10 raised to the power 9 is plus 9, while 10 raised to the power minus 3 is minus 3, that is to say milli. Okay, milli and giga are being multiplied, and hence the resultant of milli and milli multiplied with the giga will be equal to mega or million. Okay, once again, milli multiplied with nano becomes equal to million or mega. Okay, so our t becomes equal to 2.90 into 10 raised to the power plus 6 Kelvin divided by 700. This alternatively becomes equal to 2.90 into 10 raised to the power plus 4 Kelvin divided by 7. Okay, because we have removed two zeros from 700 in the denominator, and accordingly 10 raised to the power 6 will be reduced to 10 raised to the power plus 4. Okay, Now in the next step we have rearranged 2.9 as 29. That is to say, we have shifted decimal one step ahead. Due to this arrangement, our 10 raised to the power plus 4 will be converted to 10 raised to the power plus 3. Okay, quite simple. Our T will become equal to 29 into 10 raised to the power 3 Kelvin over 7. Now 10 raised to the power 3 is kilo 1000. So equivalently our T will become equal to 29,000 Kelvin over 7. And when we divide 29,000 by 7, we get 4142.86 Kelvin. Okay, and hence our temperature T finally becomes equal to 4142.86 Kelvin. Now we move to part B. Dear students, quite similar will be the part B. Part B, T is equal to 2.90 into 10 raised to the power minus 3 meter Kelvin divided by 3 centimeter. We know that centi means 1/100th part. That is centi means 10 raised to the power minus 2. Okay. So our T alternatively becomes equal to 2.90 into 10 raised to the power minus 3 meter Kelvin over 3 into 10 raised to the power minus 2 meter. Dear students, now meter will be cancelled from numerator as well as denominator, and our T will become equal to 2.90 into 10 raised to the power minus 3 into 10 raised to the power plus 2 Kelvin divided by 3. So it means 10 raised to the power minus 2 in the denominator is equivalent to 10 raised to the power plus 2 in the numerator. Okay, that is to say centi in the denominator is equal to 100 in the numerator. So in the next step, we have rearranged 2.90 as 290, and due to this arrangement, our 10 raised to the power minus 1 will be changed to 10 raised to the power minus 3. Okay, it is quite simple mathematics of school level, okay, middle school level, or perhaps primary school level. Okay, so our T alternatively becomes equal to 290 Kelvin divided by 3000. Why? It means 10 raised to the power minus 3, that is to say milli in the numerator is equivalent to kilo in the denominator. So 10 raised to the power minus 3 in the numerator will be treated as 10 raised to the power plus 3 in the denominator, and hence that 1000 will be multiplied with 3 and it will become 3000, and hence equivalently our T will become equal to 290 Kelvin divided by 3000. Okay. In the next step we have removed 1 0 both from a numerator as well as denominator, and hence our T has become equivalently equal to 29 Kelvin by 300. Okay, and this, when we divide 29 by 300 we get 0.097. Okay, and hence equivalently our temperature T becomes equal to 0.097 Kelvin. In the next step, we have rearranged 0.097 as 0.97. That is to say, we have shifted decimal one step ahead, and due to this arrangement, we will have to multiply it with 1 over 10 or 10 raised to the power minus 1. In the next step, we have rearranged 0.97 as 9.7, and due to this rearrangement, due to this change of pattern, our 10 raised to the power minus 1 will be increased to 10 raised to the power minus 2 Kelvin. Okay, and hence this is the answer of our part B. Okay, and hence in part B, temperature T finally becomes equal to 9.7 into 10 raised to the power minus 2 K Kelvin. Now part C. In part C, temperature T becomes equal to 2.90 into 10 raised to the power minus 3 meter Kelvin over 3 meter. Dear students, here meter in the numerator and denominator will be cancelled, and our temperature T will equivalently be equal to 2.90 into 10 raised to the power minus 3 Kelvin divided by 3. In the next step, we have rearranged 2.9 as 29, and due to this rearrangement, our 10 raised to the power minus 3 will be increased to 10 raised to the power minus 4. Okay, and hence our T will become equal to 29 into 10 raised to the power minus 4 Kelvin divided by 3. This alternatively becomes equal to 29 Kelvin divided by 30,000. Okay, that is to say 10 raised to the power minus 4 in the numerator is equivalent to 10,000 in the denominator, and when 10,000 is multiplied with 3, we get 30,000. Okay, and hence our temperature T becomes alternatively or equivalently equal to 29 Kelvin divided by 30,000. This alternatively becomes equal to 9.67 into 10 raised to the power minus 4. Actually, dear students, we have divided 29 by 3. Okay, we know that if 27 is divided by 3, we get 27. But here in place of 27, figure is 29. That is why in place of complete 9, we get 9.67. While 10,000 in the denominator is again shifted to a numerator in the form of 10 raised to the power minus 4. Okay, and hence up to this step, our temperature T becomes equal to 9.67 into 10 raised to the power minus 4 Kelvin. In the next step, we have rearranged 9.67 as 96.7. And due to this rearrangement, our 10 raised to the power minus 4 will be changed or increased or enhanced to 10 raised to the power minus 5 Kelvin. In the next step, we have rearranged 96.7 as 967. That is to say, we have shifted decimal one step ahead. And in shifting decimal one step ahead, our 10 raised to the power minus 5 will be changed to 10 raised to the power minus 6. And hence our temperature T will become finally equal to 967 into 10 raised to the power minus 6 Kelvin. And we know that 10 raised to the power minus 6 is a micro, and perhaps we can write it as 967 micro Kelvin. But perhaps micro is not here appropriate. Actually, dear students, I have not seen anywhere micro Kelvin. Okay, while there is no irregularity in writing here part C answer as a temperature being equal to 967 micro Kelvin, but I think we should not use here micro. It is more appropriate in this form. Okay, so our solution of part C finally becomes equal to T equal to 967 into 10 raised to the power minus 6 Kelvin, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.